Hi, my name's Bob Greenyer, and I'm a volunteer with the Martin Fleischmann Memorial Project. So thank you for joining me this 22nd October 2023 for Thor Looking Deeper. How is everyone? Hi Ken Pratt, hi Gordon Doherty, hi for Thor Looking Deeper. Tony Yaboni, hi Fused in Carbon, hi Cosmic Dave. Hi, Tammy Watkins. Great to have you here. Hi, Artifact. Hi, Matteo. So, as at least one of you knows on the chat there, the image you see on the screen there is of a vase of ours in the British Museum, in the sort of Greek antiquities section. And I chose it because it's rather lovely. It has this 4-3-2 concentric circle type structure with an O in the dead center. So I thought that was rather lovely. Hello, Stephen B. Halls and Lucas. Hi, Christopher F. Nathan Ford, Glenn Schwizinger. Hopefully I said that right. Hi, Stuart N. So I'm going to introduce a concept tonight, which I didn't get to talk about in the presentation in Switzerland, that might explain some of the observations that have been claimed for this technology. And not necessarily all of them, but I think probably most of the ones that I have personally witnessed. Then if anyone wants to ask me some questions about how I felt about so far, the openness, the way forward, and anything else, fire away. But got some exciting things coming up next week. One is that hopefully on Tuesday I will have a look at the samples that I took from the inside sphere of the 400 kilowatt natural gas powered electric generator, the grid tied one. And I have some news on that. Apparently they have been given the go ahead to modify it as they see fit. So before, as you may be aware, they were unable to modify it because of restrictions, but I have been informed that they will be able to modify it and do a proper job on it, apparently like the one was done in the long-term testing in Australia, in Melbourne. So hopefully then we can see some of the more interesting claims come to the fore. Now, when I was inquiring about the inside status of that sphere inside the exhaust of the large Thunderstorm generator in the UK, Malcolm told me when that was installed, it was beautiful, shiny steel. Well, it certainly didn't look like that when I threw the camera in there. As you may recall, if you haven't seen that, then it's the no carbon video. Okay. So if we are seeing essentially just rust, that may be not something that's unsurprising since the metal is getting very hot. One would expect the steel to last a little bit longer, but maybe not. There will be water from rain getting in there. There is also the hot steam that is coming out of the engine itself. And so one might expect it to produce rust. But if we see iron-rich crenellated microspheres, as we know, come out of these clusters, that would be very, very interesting indeed. For me, that would be one more potential categorical proof that exotic vacuum objects, fractal toroidal structures, aka ball lightning is involved. And for me, the on-ramp was the willingness of Malcolm Bendall and his team to be open with me and not restrict me in what I could say at any point. After I had witnessed the video where there was these intense north-south flux loop glowing objects going in and out of a reactor's thunderstorm generator in Thailand. So I will be going a little bit over some of the things that I talked about in Switzerland, in Zurich. I did witness essentially a thunderstorm generator being built, all bar the slap together of the bubbler and the actual construction of the double sphere ended thunderstorm generator itself. But the rest of it was essentially pipe work, and not that good pipe work. Now, the really good thing is that the one that we used there, or rather that I witnessed being put together and run there, that was given to the people that helped construct it from Germany, Thorsten Ludwig, Dr. Thorsten Ludwig, and Klaus. They took that to Germany, and I understand, and you've even seen pictures. I don't know whether I can share those. Maybe I will, if I can find them. They have modified that to put in various valves and stuff, and it's gone kind of like further away from the ideal. The ideal is that you have nice, smooth, curved copper pipes with the least fittings possible, particularly the least brass fittings as possible, and the least curves in it. Well, there's lots more curves in it. But anyway, if it still works, that's interesting in its own right. And it might point to the discussion points that I have today. Other than that sample that I took from the large generator, I also exposed some 400 ASA film at the time, and I will be looking for a developer somewhere here to develop that, to see if from the large thunderstorm generator there potentially are any birdies on that 400 ASA film. I did purchase some Instamatic film to do some tests in Switzerland, but given the fact that I was expecting to see a fully built reactor when I arrived, and there was nothing but a recently torn apart generator and a bunch of pipes when I arrived, that there wasn't the time to do that testing. However, I will be doing a whole bunch of testing when they have got 3 generators of various engine sizes running in the UK, and when they believe they are seeing no carbon dioxide and carbon monoxide. I have requested, and there has been no barrier put up as of yet, for me to take some gas sampling vials. These are vials that you can commercially buy that are pre-vacuumed with a stainless steel capsule, and you basically put that into your sampling port and you open the valve and it sucks in a sample of gas, and then the idea is that we get those over to Alan Goldwater on the Cirrus 2 quadrupole mass spectrometry gas analyzer that we have in California, and we then look to see what the gas contents is of that gas capsule. So that is what I want to do, because I want to really understand whether, and you'll see, I'll talk about this more today, whether there really is this disappearance of CO and CO2 in these particular reactors, and I will discuss some points about that. But before we go there, I have something interesting here, which was given to me by Malcolm, and that is this. This is one of the large fish tank bubbler blocks, or a suitable material for doing the same thing, that came out of the 400 kilowatt grid tie generator in the UK. And we are going to look at this live on camera. He seemed to be quite excited about something like this brown spot here, something like that. So we'll have a look at that in a second. we'll have a look at the overall structure. So we'll have a look at the overall structure first, and we will then look at that little brown spot, and if we can see any other brown spots, see what they look like under the dino light, which I have here on the right. So let's get that over there. Hopefully we can get some good visuals out of this. Right. So what are we going to look at here? This is under the dino light right now. So I'm going to put it into focus. This is on 50 times magnification. Okay. Now, using this as just a web camera, I can't really adjust the luminosity, the brightness, so you just have to take it as it is. But if we go into the 200 times setting by changing the zoom ring here, the light is not so strong anyway. Okay, so this diffuser that creates these bubbles looks like some sort of sand that may be partially sintered together. Okay, so I guess it's got these large, and they look like not sand that you would get off a beach. They look like fragmented sand. So maybe I will take a sample of this, scrape it off, and maybe gold coat it and assess whether it is silica or some other element based. Probably is silica. You wouldn't want something that would maybe change the chemical makeup too much of a fish tank, tropical fish tank or whatever. Obviously sand is there in the beach. So let's come back out of that and we will have a look, if we can, at that area that he got excited about and see what it looks like. Okay, so now these were taken out because they weren't getting enough air through this, because it was too fine for the amount of vacuum that they had at the time. I don't know whether they got them in there. I don't think they have them in there at the moment. So somewhere over here. Okay, there we go. All right. So this is a mark. Is it anything special? I don't know. Let's get it in focus. Okay. There we go. Does that look like a ring structure? Does it look like two half moon shapes? I don't know. That is what we are seeing here. Let's see if we can zoom into 200 times roughly. This is around about 200 times. So there we go. Some kind of deposit on there. Could this be a mark, like a ball lightningy mark, a plasmoid mark on there? I don't know. Maybe I can find a way to cut that specific thing out and find out what that deposit is on there. Okay, I'm going to have a look to see any of this other small ones here. There's a whole bunch of them in different places. Zoom out of that. I guess I could have brought the stuff that I removed from the inside of the exhaust, but I didn't really want to contaminate any chance of contaminating it. So I thought I'd keep that away. Oh, so here's a little other brown one here. There's a couple of brown ones here. Now, are they just brown grains of sand, or are they something more interesting? Let's go in a little deeper. Definitely looks sandy to me. Sintered sand. These particular ones look like little grains. Maybe not, I don't know. There we go. Okay. Some more over here. So this is just a quick and dirty look at this. There you go. There's a couple more of these deposits. So it'd be interesting to see what one of these deposits are. Because it is non-conductive, we probably have to do some gold coating on that. And let's see if we can do that. Yeah, maybe it's recycled glass shreds. That kind of sounds like it. I think probably you could go and look up and find out what these bubblers are made of. And it will tell you something like that. Anyway, so that was a little bit of a live microscopy to get us in the mood. And I think probably we are going to look at some of the claims that were published at the end, which I shared in a video today. If you haven't seen them, we can look at them now. So these were made after the presentation was given, and I have them here. So let me just see if I can find that. And I hope the full slide deck will be published soon on Strike Foundation or wherever it is they wish to publish this thing. So the first was this, which was the Perkins gas engine one that I actually witnessed. Okay, so here you can see. Now I think the cat base here is from the one that they had, and maybe Malcolm will come in at some point and correct me on this, but I think this is the one from Australia, maybe. And here's the CO2 is at base is normally 9.6, and the CO is 4.52, and the O2 is 0.55, and the hydrocarbons is 657, and then the NOx is 313. And with this one down here, we have the plasmoids on down here, and a different probe location. I think this might have been the test I actually witnessed. 200, 250, 280 kilowatts. They might have taken sampling points. There was 3 people taking samples at the time. I think 2 of them were feeding off the same device, and the person on site was taking his own, and I think these might have come from those. He actually had the control, and it was actually like it was quite cool actually. It was like an app on his phone, and he could control the generator and its synchronization with the grid. It was actually quite impressive to see, to be honest, this huge machine being controlled by this little phone. Anyway, so anyway, if you can see down here, essentially, there's a big reduction here in CO2, 41%. CO is basically gone. It's 98%. Now, CO for me is essentially a poorly combusted hydrocarbon. And so one might imagine if you're getting much better combustion of the hydrocarbon, you would expect the hydrocarbons to go down and the CO to go down. Okay. Here we've actually got, looks like it's going up here. It's gone up there, but down here it's gone down when it's actually under load. So anyway, this does look like the CO has gone down, and it does look like the hydrocarbons have very significantly gone down. The oxygen looks like it's very significantly gone up. But the CO2 isn't zero. Okay? It's not zero. Now, in this particular location, this is the one where they couldn't modify up until they've been, I think, given permission now. They can properly modify it. So they had to kind of like bolt stuff on the outside rather than create custom manifolds or whatever. So in this scenario, it's less than optimal. But unfortunately, I only saw this experiment and the one that was done in Switzerland, which gave this same kind of dropping of carbon dioxide, which you would imagine would be better combustion. Same story with the HCs. And the oxygen obviously being not nearly zero or very low percentages, being fairly high, and the CO2 dropping down. So I want to talk about potentially a hypothesis that could explain this data. The one that's a little bit harder to explain is the petrol and tip gas one. Now, this is actually on the same site, but rather than only doing everything half-cocked, I thought I would do proper videos and capture material with the large generator first, because there'd been a lot more exposure of the smaller generator in discussions. And so anyway, it's what they call a Chinese Honda, Honda. Maybe this is actually a Honda in their case. And they have this data here with the plasmoids off, as it's called. And you get this 9.3% CO2, 5.48 CO, 4.66 oxygen, and this level of hydrocarbons and NOx. And this is where the data is really rather, this is where I need to do more verification, because I haven't seen this. I have not seen this up close. And my question is, as I said in my presentation, could this be a means it arrived at because of the detection method doesn't work, and for some reason it's not working? But you know, maybe. But what I can say is, when the thing is operating, you don't smell a lot of hydrocarbons. And you know, if I'm hanging around by an exhaust where it's kicking out 5.48% carbon monoxide and it's in confined space, I would imagine that I would get a headache and fall over rather quickly. So you know, certainly the smell wasn't there. But then there are other things that might be produced which could be odorless, and so these things need to be investigated. So this same generator, they can switch over from petrol to tip gas, and this was the other piece of data that was showed, the Honda with tip gas. And again, with the tip gas, you have this big drop. But interestingly, the carbon monoxide is already low here, but it still gets reduced. The oxygen seems to go up, and so it's interesting. But where is the carbon going? Now, when it comes to the big device, this particular client is only interested in the carbon monoxide because they have a limitation with how much carbon monoxide they can run in a particular area. And so I think it limits them to 4 generators in this particular area, but they can actually host a whole load more. And the reality is that if the limit is 4 times this means you've got 4 times this amount per generator. Oh, sorry, 4 times the amount coming out from one generator. But if that's going from 4.52 down to 0.09, it means that they could basically stack out this whole area that they could fill with generators and maximize their return for their investment. This is over and above any potential gains they might gain from any extra efficiency. So that alone is beneficial to this particular customer, and that may be the case for many customers. And the reality is, actually, Malcolm told me that in the Maldives, basically every island hotel has one of these generators, which is desalination and electricity for the island, or rather for the hotel. And if they say 13% of their fuel, they use 13% less. That is an enormous saving for the hotel. An enormous saving. Secondly, it's actually better for the environment straight up. And then thirdly, they don't run the risk of killing their hotel, customers with carbon monoxide poisoning. And actually, that is a reality for generators all over the world. There are, I would say, probably someone could go and look, but I would imagine it's not more than hundreds, not more than thousands. No, sorry, it would be more than hundreds, certainly more than thousands, maybe more than 10,000, maybe even into the hundreds of thousands of people that suffer from or die from carbon monoxide poisoning from generators. So the idea that you could have a device and that these could actually be installed, just ordinarily onto a generator. Okay, yes, so you have to add water in. Well, is that such a bad thing? Yeah, I mean, typically with these generators, you have to add oil and petrol, for instance. So it's not that much more to ask to put a little bit of water in to have it run, so that it's much, much safer for you to have, let's say, near your caravan or near your small holding or in your cabin or whatever it is, or nearby your cabin. So there are real societal benefits without this actually involving any sort of transmutation, without this involving any sort of massive earth-shattering efficiency. And these are things that people would be interested in. So if you go and actually look at an advert for one of these beautiful little generators that you can take camping with you, often they will say there's a carbon monoxide warning system built in. And that's because it is a real threat to life. You can't smell it, and it can cause you permanent brain damage, permanent brain damage and death. And so I would urge anyone that considers getting involved in replicating this technology or attempting to find out whether it's any good, to make sure they're doing it in an extremely well ventilated environment, and that they actually know what they're doing. This is not something that you should be exploring if you are not going to take the right precautions and understand what you're doing. Okay, so that being said, I'm going to run through a bunch of the points that I made in the presentation in Switzerland, a couple of clarifications and so forth. And of course I don't have the device to wave my arms against, but anyway. Now, I gave a rough hypothesized process. I'm saying that water in air leads to protons, atomic hydrogen, plus electrons, all paramagnetic. So protons and atomic hydrogen, that is a hydrogen with an electron, is paramagnetic, or rather they have a magnetic moment, and electrons and free electrons all do. OH radicals and other ions, for instance, there's nitrogen in there, potentially you can get that. So where I'm coming from there is, if you've got a thunderstorm in your air, in the atmosphere, we have, if I press play here, in our atmosphere, we know over Hestalen there is such a thing as ball lightning. Okay, and I've talked about this in the past. And when Massimo Teodorani, an astrophysicist, and Gloria Nobili, a physicist, recorded this particular ball lightning between the 5th and 18th of August 2002, that is when the water vapor in the air was around about its maximum, around about 10 to 10.5 grams per meter cubed. So, if these, sometimes these things are like 10, 20 meters across, like the size of a house. So within that volume, there can be quite a lot of grams of water. And of course, we know we get, this is actually a photo from this study here. This Embla 2002, an optical and ground survey in Hestalen, this iron-rich crenellated sphere. So in an atmospheric air, we have 78.084% nitrogen, according to NASA, I think this is. Oxygen 20.946, argon is most of the rest at 0.934, And of the remaining 0.04338%, the majority of that is CO2. But still, the amount of CO2 in the air we breathe is incredibly small. It's 0.0407%. It's very little indeed. And then of the rest of the gases, there's almost nothing there. In terms of what hydrogen is in the atmosphere, that is almost nothing. Almost nothing. So, the things that are significant really in the air are nitrogen, oxygen, argon, and this water vapor. And the water vapor is something that's the big variable in there. So, now, we've said how oxygen is extremely important in this process from the work of, well, basically a lot of low energy nuclear reactions is in fact HHO. That is to say, water is involved, whether it's DDO or HHO, it doesn't really matter. There is water involved, and that has oxygen in it. And in the case of Sundaresan and Bockris, they only got these iron-rich crenellated spheres when they actually had oxygen dissolved in the water. So I believe that oxygen is very, very important. But we know that hydrogen also is, according to Shishkin and Karols and Dubovik, 2,000 to 4,000 times easier to create etheric matter than any other element from lithium onwards. And we have basically no hydrogen in the atmosphere to note. And so water is the greatest source of hydrogen in our atmosphere for the formation of ball lightning. And why do I say that that might be what helps us produce ball lightning? Well, I refer to the work of Matsumoto and what he called itonic clusters. And for those that weren't clear what an itonic cluster was when I presented in Switzerland, you can go and read this and download the book or get it on Amazon, but you can download it off remoteview.icu. But anyway, an itonic cluster is where a bunch of electrons polarizes a nucleus, let's say it's a proton, so much so that it emits a neutrino and a positron. And the positron and the electron gets bound by the neutrino into what Matsumoto calls an iton. This happens over and over, and it forms a cluster of these itonic bound structures, and in the center you get neutrons. That's what he thought. But regardless of his view on that, he says that his itonic clusters are effectively the same as ball lightning. And in a proposal to the proceedings of the 25th Linear Accelerator meeting in Japan in July 12th to 14th, 2000. So this will be after he wrote his book, Steps to the Discovery of Electronuclear Collapse. He made this proposal for making effectively micro ball lightning by using bunched electrons with high energy and protons with high energy. So my hypothesis effectively was that if Malcolm was to be achieving the formation of micro ball lightning, that in his ionizer here, which has a UVB 100 class 5 26 watt from America PET lamp. This is for deserts use. It's for allowing lizards in pet lizards and pet tortoises the ability to fix calcium into their bones and give them strong bones, etc. These things are commercially available. Their spectrum typically goes no higher energy than 300 nanometers. And the air is sucked in here and comes through this tube. Now, the hypothesis is that this will lead to the formation of OH radicals. And he actually states that in the bubbler, that becomes alkaline over time. Now, if you're splitting water vapor in the air using this UV light, and if you can imagine you have water vapor in your sky and the higher you go up, the more intense the UV light gets from the sun, then one might imagine that that creates some splitting of the water vapor potentially in the air, and that then you have a little bit extra hydrogen going on in there. You've got a bit of charge separation. It's not necessarily all about the static claimed from the downdraft of cool air and the updraft of warm air is produced. The static could be, and the charge separation could be happening by UV processes, high energy photon processes. Well, let's assume that that is occurring, and we are forming our toroidal clusters here of coherent electrons and the ions in there, principally the hydrogen in there. Then what we don't want to do is produce ozone, because that is far less paramagnetic than oxygen, and the clusters can't bind to the paramagnetic oxygen, and then the oxygen itself can't then cluster together in larger clusters. So we want to definitely produce bunched. How do we get bunched electrons? Well, I will talk about this maybe later in the week, but I have some concepts around how we can increase the bunching. But what I proposed actually during the presentation was titanium oxide. And the reason is, I think titanium oxide is like metal itself. So that would be titanium oxide as a film, or a doped version of titanium oxide on titanium metal. It's hydrophilic like the metal is, and it allows for photocatalytic splitting of water. Now, the 300 nanometers is technically just about capable of doing it. I think it's more than capable, in fact. But anyway, you also want the photoelectric effect on titanium oxide. You could use zinc oxide here. You could use copper oxide for the photoelectric effect. And I described how that is available in the copper pipe that goes subsequent to that. But you need potentially to increase your rate of water dissociation. And so you get a lot of free hydrogen available. And at the same time, you want to have a whole bunch of free electrons, and to go through this ionization, this cluster forming process. Well, if we do get to the point of producing these clusters, Ken Shoulders was very clear that in the white state, let's say this is, you are able to produce white state clusters, they spew out 2 kiloelectron-volt electrons in all directions, and we only need, let's say, from titanium, I think it's 3.2 electron volts, and from copper, I think it's 4.3, certainly less than 4.5 electron volts for photoelectric effect. That is actually the thing that Einstein won the Nobel Prize for. And so the reality is that if you have something, let's say your band gap, your how should we put this? Your work function is, let's say, 3.2 electron volts, and you've got something that's coming in at 3.21 electron volts. The free electron that comes off is not moving very fast. It's not very energetic. But if you've got something that's coming down at, say, 4.8 electron volts, like you would get maybe from the non-ozone producing line of mercury, which is typically in all these kind of UV disinfecting lights and stuff. If that's coming in at, say, 4.8 electron volts, then the emission of the free electron will be a lot more energetic. And therefore, you've got more chance, in my view, of producing any clusters. Well, if you do get the clusters, then and they do start to condense, then they will allow these 2 kiloelectron volts to come off. And then as we are going through the copper pipe here, from this down here, there will be an oxide layer in there, and so as it's condensing, you would hope that it would feed back more electrons that would build the structure and build the structure. The reality is, in all of these situations, you would probably want the metal to have a negative bias, and I don't see it in these things. Could it be a chemically produced negative bias? I don't know. it might be that you could electrically couple it to the engine, and that there is some blowing up of charge clusters and they are doing it, or maybe all of the work is done in the Thunderstorm generator as they blow up and transfer the charge. Don't know. Or you could force charge it by, connecting it to the electrical contact. I don't know, but there is a lot of room for improvement if, in fact, it's actually doing the work. But maybe it's doing something a lot simpler. A lot simpler. And it's only when you really, really push it that it's producing these exotic vacuum objects that are witnessed by these things moving around. And that is the really interesting thing, but that isn't what's achieving most of what we're observing. I'll explain in a little while. So, I also described about the Armstrong electrostatic boiler here. And from this source that's given down the bottom, and I will share these slides, he's saying that this, essentially what you've got like some coal or wood in here, and that's burning and producing steam in the boiler section here, and you've got the water level or whatever, and that's producing very high temperature steam, and he has a valve which he can crank and let the steam come in here. There's a suggestion that there's cooling water in here, and that the cooling water, I don't know why you would want cooling water, but apparently there's cooling water in here, and that the steam comes through, and as it comes through this very circuitous area, and then through this capillary and out here. And as it comes out, the steam jets hits these little needle electrodes here, and they capture static electricity, which can produce up to 2-foot sparks. Now, that is a lot of voltage. That's a very high amount of voltage to do that. Now, I don't think the person that wrote this was able to look inside this device. And whilst the rest of it seems relatively clear, I actually think what might be going on, and again, this is my speculation, so his speculation was this was cooling water. My speculation is that you've got superheated steam here, potentially at hundreds and hundreds of degrees, and it comes through here, and it actually flash boils, producing intense cavitation, or rather, it just heats the water. So this is steam, but it heats the water that's in here to super heated water. So it's still water, but it's like in a pressure cooker, but it's actually still water because it cannot, it cannot escape. And that, to me, explains why this is a very, very thick thing. This is a very thick thing. This is a very thick thing. And I think what might actually be happening is that steam is effectively going through a bit of a heat exchanger here. And it's actually just the steam that's been through that heat exchanger that then comes out and into the exhaust from the flue, from the burning hydrocarbon down here. And so I don't think this is just cooling water that's then boiling off. I think this is the residual steam that's coming from up down here. Now, what that means is that you've actually got hot water that hydrodynamically gets vorticized around here in multiple aspects, and then it comes into this capillary where it becomes a toroidal soliton already with complex hydrodynamics going on in here, and it comes through this capillary, to this point, at which point it goes from the extremely high pressure in here to extremely, 1 atmosphere. And so it instantaneously turns to steam at this point. And in doing so, you have a toroidal structure that instantaneously turns to steam, and therefore you might have this intense charge separation in a toroidal vortex here, which will project the charge through to be caught on these spikes. That, my friends, is how I believe that this is going on. Okay? That's how I believe this is going on. But I think also that something similar might be going on in the Thunderstorm generator, because actually, when you come into this bottom sphere down the bottom here, which you can't necessarily see, but you could on the very large one, when you come into that particular... where is it? Blah, 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 blah. When you come into that bottom one, it's very hot, and the metal probably is around, I think from the thermal imaging, it was at least, 200 or 240, 250 degrees centigrade. That would be flashing to steam. So maybe a similar effect is occurring, but to potentially a lesser degree, and you get some charge separation going on from down there, which means it's charged, and of course the plasma coming out of the engine is going to be charged, and it's forced into two vortices. Now this is where I need to introduce the data that is being shared by the person that has been doing a replication. I think it's in New Mexico. And actually, this is quite exciting news, because Malcolm Bendall has agreed that he will give the MFMP, or supply the MFMP, with a forset for conversion of the Golf 1300cc engine that was acquired for Henk Uren, who is going to do it as a GEAT and may still do it as a GEAT. But if we get this kit to apply to the 1300cc engine, we'll be able to have a direct analysis of a car engine. It's a Golf 1300cc engine. Also, we'll be getting kit for Tony Yaboni, apparently, with the bubbler, and these actual double-ended vortex tubes are being produced as we speak. And they will be supplied, as I understand it, at no cost to the MFMP. And also, someone has expressed an interest, and so if he's there, it would be good. He's in Coventry, he knows who he is, and he has got a person that wanted to do this. He actually was one of the few people that really published a lot of his work on doing the GEAT replications earlier in the year. And so it looks like we'll be able to get one out to him. And so he's really being helping and being honest about getting this material out for people doing replications. Okay, so let me just get this slide up. Hi, Kim. Nice for you to join us. Okay, hi, Gweet Tosan. Hi, DIY Projects with Chauxus. Hi, Jack Trading. Okay. So, under the THOR tab here, so if you go to the Martin Fleischmann Memorial Project, we have a subject called THOR, and of course, it's not just because Thorsten Ludwig decided to, be one of the people on the build in Switzerland. Thor is also the god of thunder and lightning, and obviously this is the Ukona Vasara, Thor's hammer, and I'm saying that this is able to change epsilon and mu, giving us the ability to change the physical vacuum and go faster than light and do all kinds of funky things. The most powerful thing in the universe. Anyway, you will see on the THOR thread there is 2 live documents here, and you can comment down the bottom if you wish. And I need to catch up with people's comments down there and add in some thoughts. But if you click on that, you can actually view it in a separate window, in theory. It's pulled it down here, but we'll put it up there as well. And we will go into here. And there's this other document here. Which again, it's dropped down there. Okay, it's dropped it in there, is it? Okay, fine. It's not doing exactly what I want. Right. So in this one, we've got like a rough of the structure of the internals of the double-ended vortex tube, the so-called dueling vortex tube in Malcolm speak. And here's the close-up of the inside. And I think he calls this the 432, maybe. So I don't see that necessarily as being 432 as I'm looking at it there. So I think probably it's a different ratio than is shown in this diagram here. Let me just check. Anyway, so this is basically the rough layout, but you could see the ones that we've shown him holding in his hand and I think it's a slightly different ratio, but you get the idea of how these are arranged. And the center one's hollow, and there's some means of connecting this one to this one, and so forth. Interestingly, you can see there's a swirl guide here being placed into this part of the device, and I think there's one also that goes at the bottom. I guess that's forcing the vortex initiation, maybe. A swirl guide, yes, it's actually detailed here as a swirl guide there, if you can see it. Okay. Now, if I go back, this is the public document. Now, the interesting thing I want to do is this work is being spearheaded by Nikita Vovik. I hope I've said his name right. And you can ask to help out with this document. That would be great. There's a lot of things we've already clarified. Because they're talking about which alloy was used on the demonstration model, and then the power of the lamp make and model, and we know those things now, so we can go in this weekend, correct these things. However, they actually have some data, and down here, where is it? So thank you to Nikita. Somewhere down here. There's some charts, and you can go and look at this. And of course, some of these diagrams are not correct. In fact, I think so this diagram is not correct, and I think this has caused some confusion actually, because this potentially shows some of the exhaust being fed back into the bubbler. Now, this is something that was done with the Geet. Of course, this could be done with the Thunderstorm generator. However, in all of the embodiments that I've seen, the 400 kilowatt generator and the one in Switzerland, the exhaust just came out here. In fact, there wasn't even an exhaust muffler on there, much to everyone's being upset, certainly my ears. Anyway, so... And I will give a potential reason as to why, both on the Geet and on this system, this may have been beneficial. And it's not for the reason of atomic splitting, as was claimed for the Geet, of, carbon all the way down to hydrogen atoms. Okay? But anyway, going on to what I wanted to say, which is actually about the data. So actually, Nikita's got some... data here. So preliminary data results to guide discussion suggestions. This is from October the 8th, 2023. The first characterization of the continuous gas sampling system was done following the response time characterization protocol. A 50 SCCM flow of helium was enabled and disabled using a Sierra Smart Track 100 mass flow controller. The rise and fall time of the helium peak is correlated with the mass flow controller valve speed and gas sampling response time. Although all mass peaks from 0 to 100 AMU were continuously recording, only significant mass peaks of carbon dioxide, 44 AMU, diatomic oxygen, diatomic nitrogen, water, hydrogen, and helium are reported in the recorded graphs. And it may be worthwhile to check the peaks for things like methane, other light hydrocarbons. Unfortunately, carbon monoxide cannot be investigated due to its 28 AMU peaks directly overlapping with diatomic nitrogen, which is in the atmospheric background. Okay, so down here, you have the helium down here with the pulses. You have hydrogen here, so this is kind of the baseline for hydrogen. Water up here at the sort of 0.35 partial pressure coming down to 0.3. Nitrogen up here, oxygen in the middle here around this level. Okay, so based on the results obtained during the continuous gas sampling response time characteristic, the response time to 50 SCCM incoming helium is less than or equal to about 15 seconds. Okay, so that's how long it takes to know what's going on. So, right, okay. The first unloaded generator started up. Priming test began at 15:57 and the engine was shut down at 16:21. Roughly 350 grams of gasoline was consumed in 24 minutes. During this test, mass spectrometer gas analysis showed a sharp response in the exhaust gases exiting the muffler. As was expected from combustion, gas compositions indicated relative increases of water and carbon dioxide and relative decreases in oxygen and nitrogen. Interestingly, the exhaust also contained surprising amount of hydrogen gas. A surprising amount of hydrogen gas. Right. So there's the baseline, pretty much like what you saw before, or somewhere down here. This here, it says peak disruptions beginning around 15 minutes are due to the sampling inlet disconnection from the exhaust outlet. The sampling inlet was reconnected around 16-minute mark. So around the 16-minute and 15-second marks is where you've actually got the data that's meaningful here. See, the nitrogen is dropping down. The water is going up, as one would expect. You're burning a hydrocarbon. In oxygen, you're going to synthesize water. The carbon dioxide here is going up, but they say there's an issue when they're doing the calibration before, but potentially not here. And then the oxygen has dropped down, okay? But it's this hydrogen here, which is quite interesting, and he's actually blown it up here. And you see the hydrogen goes from way down here all the way up to here, okay? So what is this indicating to you? Well, it's indicating to me that, you know, well, firstly, there's no helium. There's no helium, look, down here. So the claims of the GEAT that it was producing helium and oxygen, you know, that implied potentially a nuclear reaction going on. But more oxygen than you would expect and hydrogen would actually expect, it would suggest either splitting of water or some other process going on. And I want you to think about what that process is whilst I go and visit the little boy's room. And maybe you can think what it is that I'm going to be talking about as we move forward. Can anyone guess what I'm going to say? Has anyone guessed already? Let me have a look. Has anyone guessed what I'm going to say? Creating awareness is not far from the truth. He's calling it the wrong thing. Not far off. Right. Let me just get a few slides up here. You don't need to be a scientist. This is the beauty about open science. You can just actually have a clue. So about 10 years ago, maybe 12 or 13 years ago, I was walking around one sunny day here in Brno, and there was a bunch of guys, and they were over from Qatar, and they were saying, we need to find this place over here, blah blah blah. And I said, oh, okay, you look like interesting guys. What are you over here for? Well, we're over here from the Qatari blah blah blah, and representing them, but we're actually all English. And we're here, we're visiting an engineering company, and they are making some devices for us, and we're going to be doing some tests on them, and la 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 la. And I asked, you know, what they were, and so forth. And they said they were making hydrogen reforming towers to kickstart the hydrogen economy. Okay? Does anyone know what that is? Does anyone know what that is? So you weren't far off. You're kind of like in the right area. Okay. So, hydrogen production. This is on the Office of Energy and Efficiency and Renewable Energy for energy.gov, I guess, in the US. We're going to have a look at this now. Hydrogen production, natural gas reforming. Natural gas reforming. Natural gas reforming is an advanced and mature production process that builds upon the existing natural gas pipeline delivery infrastructure. Today, 95% of the hydrogen produced in the United States is made by natural gas reforming in large plants. Now, I thought about this today, and then when I thought about it, I actually remember that Malcolm actually said this in his talk or something like that, like 90% or something like that. Anyway, or maybe I'm just misremembering. But anyway, today 95% of the hydrogen produced in the United States is made by natural gas reforming in large central plants. This is an important technology pathway for near-term hydrogen production. How does it work? Natural gas contains methane. Ba-ba! That can be used to produce hydrogen with thermal processes, such as steam methane reformation and partial oxidation. Steam methane reforming. Most hydrogen produced today in the United States is made via steam methane reforming, a mature production process in which high temperature steam, 700 degrees to 1000 degrees C, is used to produce hydrogen from a methane source, such as natural gas. In steam methane reforming, methane reacts with steam under 3 to 25 bar pressure, 1 bar 14.5 psi. So this is 3 to 25 atmospheres. So this is a lot of atmospheres. However, potentially you could get a lot of atmospheres inside the cylinder, right? In the presence of a catalyst to produce hydrogen, carbon monoxide, and relatively small amount of carbon dioxide. Steam reforming is endothermic, that is, heat must be supplied to the process for the reaction to proceed. This is not going to work. So this won't work for a number of reasons, initially, thinking about it. One is, heat must be applied to the process for a reaction to proceed. And 700 degrees C is over 660.3 degrees C, the melting point of aluminium in our engine blocks where we are testing these. And 1000 degrees C is over the melting point of the brass in which we used for fittings. However, actually, Henk did in a Geet experiment, and I asked him if he could get the image to me. He did in a Geet experiment end up by having a brass fitting turn to like jellify and melt. Now, was it because of this? Was it because hydrogen was being produced and it ended up doing something, or was it because the charge clusters went into the and messed up the copper that's in there because it's a spin nuclei? Because we know it can do that. We know it can do that. So what's going on? Well, when we were looking at the reactor in Switzerland, it didn't seem to exceed around about 460 degrees centigrade on the exhaust, and that is well below the 660.3 of the melting point of aluminium. And again, the temperature coming out of the exhaust in the gas one in the UK, again, that was in the 450 degrees centigrade or something. So it is well below the temperature required, and you know, maybe you're getting the pressure inside the cylinder, but maybe not elsewhere. Anyway, subsequent in what is called water-gas shift reaction, the carbon monoxide and steam are reacted using a catalyst to produce carbon dioxide and more hydrogen. In the final process step called pressure swing absorption, carbon dioxide and other impurities are removed from the gas stream, leaving essentially pure hydrogen. Steam reforming can also be used to produce hydrogen from other fuels such as ethanol, propane, or even gasoline. So, we can hydrogen reform from gasoline or methane. Gasoline or methane. Those encompass all of the fuels that are claimed to work with this system. Okay. So the steam methane reforming reaction is this: CH4 plus H2O plus heat. This is the problem. You're going to have to put heat in to get the carbon monoxide and the 3H2. And then the water gas shift reaction is CO plus H2O goes to CO2 plus H2. So ultimately, from your CH4, you get CO2 and 1, 2, 3 count them, and 4, that's 4 H2s coming out by splitting the water effectively and capturing the oxygen from the water. Okay. Now, there is another process called partial oxidation. In partial oxidation, the methane or other hydrocarbons in natural gas react with a limited amount of oxygen, typically from air, that is not enough to completely oxidize the hydrocarbons to carbon dioxide and water. With less than the stoichiometric amount of oxygen available, the reaction products contain primarily hydrogen and carbon monoxide, and nitrogen if the reaction is carried out with air rather than pure oxygen. Okay? And a relatively small amount of carbon dioxide and other compounds. Subsequently, in a water-gas shift reaction, the carbon monoxide reacts with water to form carbon dioxide and more hydrogen. Partial oxidation is an exothermic process. It gives off heat. The process is typically much faster than steam reforming and requires smaller reactor vessel. As can be seen in chemical reactions of partial oxidation, this process initially produces less hydrogen per unit of input fuel than is obtained by steam reforming of the same fuel. So, partial oxidation, which produces heat, it doesn't require heat, it produces heat. You get CH4 plus half O2 goes to CO plus 2H. Okay? And then using the water shift reaction, CO plus H2O goes to thing. Okay, so you get 2H2 here and you get H2 there. So, right. this is when you have less oxygen, you have nitrogen in there, and you're getting a two-stage reaction. Again, you get this CO plus an amount of H2, and then water shift gas reaction. But both of these processes are exothermic. And one might imagine that if this was occurring in the reactor, then it would actually produce heat, and this might produce heat. So, like, you might be losing some heat by not properly burning the hydrocarbon, but you are recovering the heat. Let's say that the thunderstorm generator is actually doing this process. You're going to be recovering some of that heat in your actual heat exchanger of the thunderstorm generator. So, in the actual engine, you produce a little less heat, okay? But as it comes round and that heat is exchanged into here, and also the reaction that then goes on to produce more hydrogen comes down here, it also yields the production of heat. Then it can then heat the air going in. So overall, the engine might be running, is similar efficiency, and it would appear potentially a slightly higher efficiency. So in this scenario, you could have a scenario. And so I just want a couple of other points here that I think are relevant to this argument. Just finish out this document here. Why is this pathway being considered? Reforming low-cost natural gas can provide hydrogen today for fuel cell electric vehicles, FCEVs, as well as other applications. Over the long term, Department of Energy expects that hydrogen production from natural gas will be augmented with production from renewable nuclear coal with carbon capture and storage and other low-carbon domestic energy resources. Petroleum use and emissions are lower than for gasoline-powered internal combustion engine vehicles, and so on. So this is just justifying fuel cell electrical vehicles. Okay, so they're saying that this is an easier method. It can run in smaller devices and so on. And the interesting thing is here, he talks about need for catalyst in the thunderstorm generator, which you're not getting from soft iron and you're not getting from copper in this instance. And one of the catalysts for steam reforming is nickel. And then this is the pressure swing absorption. You can go and have a look at that at a later time. But nickel, of course, there's an upside that and I confirmed this with Malcolm earlier today. He is using how should we put this? He is typically used type 304 steel, which contains about 8% nickel, and ideally you would want to use type 316, which has 11% nickel. Now, I have one reservation, that if the nickel is catalyzing the CO to CO2 with the H2O producing H2, then in this scenario, you are interacting carbon monoxide with nickel, and in that scenario, one might expect you get the formation of nickel tetracarbonyl, which is highly lethal. And so, if this is the process that is occurring, maybe it occurs at one end and it's already fully carbon dioxide and H2 by the time it comes out. But if it isn't, and there is some nickel tetracarbonyl coming out, and I need to look at the temperatures and whether this would actually be possible at that temperature for any length of time, because it actually reacts at a very low temperature, then people need to be aware of the risk of this, because you can't smell it either, and it's got a very high toxicity level. So this is one thing that needs to be cleared up. But if there is some hydrogen reforming going on, this would explain a number of things. One, no carbon dioxide on the flues, because basically there's plenty of oxygen available in the overall process to produce carbon dioxide. 2, it would potentially explain the lowering of because there's water going into the process, and I'm saying that the bubbler maximizes at whatever temperature you're running the device at. It maximizes the grams per kilogram of air. So that's grams of water vapor per kilogram of air that are going into the system. And that because of the heat exchanger, that becomes steam. So that becomes definitely water gas. And that's going into the device. So you've effectively got some steam reforming potentially going on. And if that's the case, you're going to have CO2. You're going to have no CO because there's plenty of oxygen to make that to CO2 through this 2-step process. Okay. You are going to see oxygen because you're throwing a lot of water in there. So you're going to possibly get a lot of extra oxygen left over, potentially. You've potentially not even using the oxygen that's coming in with the air that's coming in because you're getting most of the oxygen from the water. Okay. And the balance is hydrogen. And so you have oxygen from the air that isn't used because you get most of the oxygen from the water. And the balance is hydrogen. And then what do you have? If you really have a system, which it looks like it is, that produces just CO2, and out of the exhaust you've got oxygen and hydrogen, well, what have you got? You've literally got another fuel coming out of the exhaust. You've got hydrogen and oxygen, right? So the idea that you can get slightly more efficiency through the overall process, you don't emit carbon dioxide, and you don't emit carbon monoxide, and you burn all your hydrocarbons, so your HCs go down. That's all a bonus. So less fuel, less carbon monoxide, less hydrocarbons. That's great. Clean exhaust, clean engine, great. But you're also getting hydrogen and oxygen coming out of the exhaust. And in that case, you could feed that back into the device. Now, not even necessarily through the bubbler, but then you're going to be wanting to remove the carbon dioxide and the water. If you passed it through a bubbler, that might absorb some of the CO2, but you might want to put the CO2 that's there through a scrubber and then pass the hydrogen and oxygen through. I don't know. This has the potential to have maybe a 2-stage process where you have one engine that is burning some carbon, how should we put this? If you put it through the bubbler, then the water that's synthesized will condense in the bubbler. So you take the water that's generated out of the equation. You just have this balance of CO2 that you kind of want to get rid of. Okay. And then you have hydrogen and oxygen that's going into the engine. So it could kind of feed itself, or you could tap that off to another engine. So I think what you also need to consider is this. I think that why you have got those plasmoids forming when you're overdriving this system on the outside of the steel, and I understand now it is actually steel, the one that went in Thailand. The reason that's occurring is there is a lot of plasma and there's a lot of hydrogen coming out of, potentially, if this is correct, this steam reforming process. And in that case, you've got a lot of free electrons in the plasma, you've got a lot of hydrogen. You could literally form EVOs, and at that point you shift from this purely catalytic chemical process through to someone that starts a process that becomes nuclear, right? Or rather, fractal toroidal structure induced moment induced reaction. Okay, so as things stand, there is one other question I have that I need to resolve, and that was to do with the non-detection of carbon dioxide and non-detection of carbon monoxide in some of the data that was shared and has been claimed. So I just need to bring something up about the way detectors work. If I can find it. Dear, where did I put that? I mean, I've got some notes here that Paul Pantone said that hydrogen is being made by the breakdown of carbon, but, you know, I'm suggesting that maybe it could just be hydrogen reforming. Similarly, it is the claim of alpha particles, the claim of helium being formed that needs to be looked at. And of course, these ratios might change just because there's an extra flood of oxygen and hydrogen, and that changes the overall ratio. So it looks like the CO2 is going down, but it's proportional because extra gas is being synthesized in the reforming process as it's going through this second stage here. Where is it? The second stage here of the partial oxidation. So you've got water gas as 1 mole and CO as 1 mole. And I guess they're both 1 mole coming out, but the water is accounted for separately. So, and the hydrogen wasn't looked at in these devices. So, yeah. So here's my point. I don't know whether I've copied it, but you can go and find it somewhere. Basically, the devices that they use for measuring the gases typically have an infrared source, and they look for spectral absorption of infrared as the infrared passes through the gas, and that's how they determine how much carbon monoxide is, carbon dioxide, nitrous oxide, HCs, and so on. And the thing is, I don't think those devices are designed to have a lot of hydrogen or expect to see a lot of hydrogen in that path of which they do their analysis. So I've got a quote here from a site that builds these devices for looking at gases. An infrared gas analyzer measures trace amounts of gases through identification of absorption levels in a particular sample of air. Essentially, this means measuring how much infrared light is absorbed in the air. If the sample has a lot of a certain gas, the light absorbs more at a certain frequency. Now, the thing is, I do know that hydrogen has the highest thermal heat capacity of any element. Okay, so if we have how should we put this? If we have this absorption, or rather this production of hydrogen here from this reforming process, if that's what's going on, then the hydrogen with its very high thermal heat capacity, thermal being IR photons, could that be absorbing so much of the IR photons that you don't see a signal in the carbon dioxide and the carbon monoxide? And, you know, it basically zeroes it out because, you know, you can't smell carbon dioxide, you can't smell carbon monoxide. So it's not like the smell test. We already know that and would expect the hydrocarbons to be burnt more cleanly, and that's the thing you would ordinarily smell. And so then you're just relying on the device to do the detection. So the water has clearly gone up here. We expect water to be formed, and the oxygen hasn't gone down by as much, and that, I believe, is because you don't need as much oxygen from the air, because you're gaining oxygen from the water to fully burn the hydrocarbons all the way through to carbon dioxide, and in the process you get a balance of hydrogen left. Now, the thing is, if you've got hydrogen this much left and you've got oxygen this much left, then you possibly could flow proportionally some of the exhaust back into the bubbler, and literally as it is in this diagram, some of it into the bubbler, and you would actually gain a lot of energy by combusting the hydrogen and oxygen to water. And again, the water that you would lose in here would be proportionally replaced by the water that's synthesized in the overall process. The only caveat with that is that there would be this build-up of carbon dioxide in there. That would increase the alkalinity. However, if you are getting splitting of the water here, catalytic splitting, that would bring in some OH, and that would increase the alkalinity. So anyway, it's a bit of a muchness. I do think there's a huge opportunity here for cleaning the flue gases, and if you are able to produce no carbon monoxide, more cleanly burn the fuel, and end up with this extra fuel at the end that potentially you could use, because it's very easy to fractionate hydrogen and oxygen because one's just a damn sight lighter than the other. So like one rises faster than the other, or you can use the process that they suggest. There's a number of ways you could approach this, and you could scrub the carbon dioxide in other ways. But anyway, so how does how do people think about this concept of it being, in part at least, without it being pushed to the limit and producing those big plasmoid structures, which is very interesting to me, that at the outset that this could at least be a hydrogen reformer based system, and that this for me explains the observed data from the initial research work done by Nikita Vivok, and this, as he calls it, this unexplained extra hydrogen that's coming out. How do people? Have people got comments on whether that might be a realistic hypothesis for how it's working? There we go. Hi, George Howard. Thanks for joining us. Needs a separator funnel for the gases to layer up for some time and do measurements at different levels. Okay. Yeah, so Gordon Doherty is saying the hypothesis fits well with the observed data. Yeah, it really does. And I have to thank Nikita Vivok for sharing this extremely important data. As I said to Malcolm from the outset, I see what I see, but my first statement about what might be going on in the device could be that it's a error in detection. So this was my second major slide that I presented, that there's an error in detection, but you can't smell the HCs, so you need a budgie for carbon monoxide. So like you can't smell carbon monoxide, so and I don't think there is carbon monoxide there. So it solves the carbon monoxide problem, it solves the HC problem, it gives you nice clean fuels, it efficiently burns the fuel, and it leaves your engine nice and clean and so forth. And if you push it really hard, some real sort of magic starts to occur, but you don't need to push it really hard. And this would explain why he's suggesting it works better when you have these steels, and he didn't specify why they would be a catalyst, but the nickel is used in catalysis for hydrogen reforming, and it would make sense that if you use 316 with its 11% nickel over 304, which is 8% nickel, that you would probably get a better hydrogen reforming process. But yeah, absolutely full-on props to Nikita Vivok for sharing that data publicly. Randall says, so this engine has 3 operating regimes. Is engine or reactor or right word? Well, I would suggest that it's at the first point, it's a internal combustion engine. Then the internal combustion engine is producing the vacuum or the power to provide the vacuum, and the high temperatures, and through the thunderstorm generator is effectively creating a hydrogen reforming process, which is essentially producing excess oxygen and hydrogen. This excess oxygen, now, like, it could be that there's too much hydrogen produced such that you actually need to pull in extra air to burn this efficiently, okay? Or if you did separate it, you could then go and use it in how should we put this, in either the engine itself or in a electrical, proton exchange membrane. But you would need to separate the hydrogen out. But given the fact that these modified generators are running cleaner, and when they're under load, they're running a percentage up to 13% or even higher more efficiently, then you're effectively getting this hydrogen reforming for free. Yeah, Martin Kemp, but a fuel cell. So if you don't want to pass it through again, then, it's... I need to understand from Nikita, or maybe someone that is better at reading this partial pressure THOR chart, to actually give us an idea of how many moles of hydrogen is being produced, how many oxygen moles are being produced, and so forth, so that we can understand how much energy there is of capability in the produced hydrogen. And you can add that to the overall efficiency if we found a way of best utilizing that. And then, because we know that it is producing plasmoids in that test in Thailand, you're getting into a whole other domain. And I think, in Paul Pantone's work, I think in his book, and I think Steve pointed this out to me in his book, that he said that he actually had a whole GEAT device disappear. And, that would be, you've got the North Monopole at one end and the South Monopole at the other end, and everything within that gets encapsulated and goes. You don't want to be going down that kind of level of, effect. But if it is a relatively easy way to start generating clusters that can do some pretty interesting and explore this interesting science, that is a whole other area. Clean engines that run efficiently, and in this case, you are able to run it on the gas that comes off a waste tip, but you're also able to use this to maybe produce energy and hydrogen and oxygen, effectively, from getting the balance on the water, from methane hydrates. And to be able to burn methane hydrates and remove the potential damage, according to climate scientists, of the methane from permafrost, which is 27 times over a 100-year period higher than the damage that CO2 of the same amount of energy yield. So, like, if you replaced all of the coal, oil, and gas that we currently use globally 1 year with 1 year's use of methane hydrates, the damage, according to the climatologist, over a 100-year period of the methane to so-called anthropomorphic climate change would be the equivalent to 27 years of burning and producing all that carbon dioxide from coal, oil, and gas. So it behoves us to burn that methane hydrates first. And apparently there's up to between 100 and 400 years worth of that to provide the current energy needs of the planet, which will give us plenty of time to work out the Lena difference and maybe transition to a more direct energy technology. So it's like stepping stones. This is potentially a very nice stepping stone that produces cleaner engines. And the other thing is here, the whole point of having a catalytic converter is to catalytically burn and remove the carbon monoxide, the nitrous oxides, and the unburnt hydrocarbons. But it's basically kind of wasted energy. It's not giving you any more prime moving force, and it's so on. And the platinum in those things, one is expensive. It like adds an extra $1,000 to a car. The second thing is you actually need a huge amount of gas to actually produce the platinum and rhodium or whatever it is that's in the catalytic converter. You're talking like tens of thousands of miles of gas is burned to produce the actual metals that are in that catalytic converter. So if this does the same job as a catalytic converter, the embodied energy in a normal internal combustion engine car would be far less than that is required by a catalytic converter version. And then the point that I made earlier, having much safer and slightly more energy efficient generators is a huge boon to everyone that has to use those around the world. So yeah, I think there's lots of opportunities here. So yes, first it's like kind of potentially replacing the catalytic converter with something that's simpler and effectively performs the same job. But it has this bonus of this hydrogen coming out, which you could possibly use in a range of ways. And then you may be able to do some magic by pushing that a little bit further. Yeah, as Gordon says, plasmoids or these were actually north and south flux loops with the material flying between them out of the inside of a steel reactor. Okay, yeah, there's no doubt about it. When those appears, you're moving well beyond combustion. That's absolutely it. But I'm saying you can get most of the benefit from this without ever getting to that point. And what I with this understanding, it you can explain the observables up to, and this is what I'm saying is, I think the CO and the CO2 may not be being able to be detected because of the abundance of hydrogen. And I think what's happening is in the rough devices, there's not that much hydrogen being produced, but in the very nicely built ones, you're getting a lot of hydrogen produced. And so it maybe saturates it out. So this is why I need to get samples from one that is claiming to be producing no carbon dioxide and no carbon monoxide, get those samples and see if we actually see those signals under the mass spectrometer. And I'm putting this out there. Malcolm does not know. I spoke to him earlier today. He does not know that I was going to say this. And I expect that this does not change because I've got a good relationship with him. And he wants to understand this as much as anyone else. And I do not expect this to change our ability to explore this and to get gas samples and settle this debate. There's one other safety concern over and above. There still may be carbon monoxide coming out, but I don't think it's basically carbon dioxide. And there's only this one potential small risk, is that in the reforming process, because potentially nickel is playing a role in that catalysis and you've got carbon monoxide in there, that maybe there might be some nickel tetracarbonyl. But I think possibly, realistically, it's probably happening so fast that may not be an issue. So I would just want to look out for nickel tetracarbonyl in devices using 304 or 316 stainless steel in the Thunderstorm generator. So did you elaborate on the magnetic attraction on the sphere? I genuinely think that there's the simple explanation potentially is that in the manufacturing there was stresses put into that which were triggered by expansion and contraction of the long arm of the steel tube that goes through. That's the simplest explanation. Doesn't really follow with the symmetrical nature there. We do know that at that point, that is where the cold end is coming in and it's flashing. And in that situation, that is like the Armstrong electrostatic boiler. You might have a huge amount of charge separation and it's going in a vortex, and that might create an intense magnetic moment. All I can say is when it was operational, that zone appeared to have the highest flux, magnetic flux coming out of it. A lot more needs to be investigated about that. I think mostly because you want to keep the device from not collapsing at a particular point when you're mass manufacturing these things. I think it's not, the field wasn't that strong. And you know, if it is just a thermal contraction thing, then that's a different question. And again, these things are just engineering problems. I think the important thing is here, you are using this, if I'm right, and I may be right, I may be wrong, but potentially you are using this simpler methane reforming reaction leading, which both of, sorry, not this one, the partial oxidation, which makes sense because you're putting nitrogen in, not all oxygen under high heat and pressure. In this situation, you are synthesizing heat here, and at this point, when you are completing the reaction, you are synthesizing more heat, and that is why the heat exchanger is great. You know, because it's raising the temperature of everything to potentially go through this reaction in the first place. And yeah. Yeah, so Martin Kemp, Geet mentions lack of grounding and puddles leads to orbs. Yes, so yeah, because that you would have these charged and fields and so on and breaking up. We know for certain that the Thailand test was producing these magnetic flux loops that are from the exotic vacuum objects, in my view. And these kind of things, because of the turbulence going on in there, because of the charged particles going on in there, all these things will be happening at a lower level. But it's like, you know, what is catalysis? Is catalysis actually just the fractal toroidal moment that actually manifest? You know, potentially. And so certainly there's a magnetic moment in a piece of nickel if it's acting as a catalyst, you would imagine. I don't know. However, the point being is that yeah, okay, all right. Okay, I'm going to see if you've got any questions. If you've got some questions I haven't answered that you want answering, drop them to the bottom. I'll work my way up. Do you know of the conditions of the Thailand test to create that effect? It was overdriven, and I think that was because of the changes of diameters of pipes. And this is something that you see in Geet as well. Alex Del Castillo Pantone talked about a small engine feeding a larger one. Yes, I recall that, and now potentially we have a reason why, because the small engine is effectively doing hydrogen reforming, using the fuel to do that, and then you could basically burn hydrogen and oxygen in the other one, which is, it might be that. And this is why I think these ratios, understanding these ratios is paramount. You might actually, because your CO2 is potentially taking some of the oxygen from the water and some of the oxygen from the air. It is dropping down from ambient air level, and it might be that there's enough hydrogen here to take the oxygen here plus a little bit of extra oxygen with nitrogen from the air and actually essentially have a whole engine running off the previous engine. So yeah, I think that might be a way to, an explanation for how that is working. Particulates typically are particles of carbon, right? P10 particles, for instance, or P30 particles. These are so Gordon Docherty says, what about particulates? Malcolm mentioned they were also much reduced. Well, soot is like an aggregation, maybe electrostatically aggregated clusters of carbon particulates, maybe 10 microns or whatever. And if you are fully burning the carbon always, either burning it or through this hydrogen reforming process, then you're not going to see those particulates, are they? So naturally, they would be not there either. So no particulates, no HCs, no carbon monoxide, just seeing extra hydrogen, as per observed, but not going to be detected in a normal gas analyzer that you would use for a vehicle, and no particulates. So I'm saying that because I think the way that those particular detectors work, they use infrared, and the infrared possibly gets absorbed by hydrogen, which has this incredible heat capacity, and as a result, it doesn't see the carbon dioxide. The carbon monoxide's not there, but it doesn't see the carbon dioxide. And also, there's extra oxygen because not all of the oxygen was used from the air coming in. So the carbon dioxide has gone down, but it's a relative thing, isn't it? You've got these extra moles of hydrogen which shouldn't be there. Not all of the oxygen was used, and then you've got possibly the same amount of carbon dioxide, but relatively, it's of the gases. It appears to have dropped, but it's actually possibly maybe even slightly increased. But you've got 2 other moles of other gases, let's say, but not necessarily that exact ratio. So Glenn Schrishinger says, Bob, did the lack of gamma radiation outside of background suggest to you rather early something else was going on? No, I took the gamma radiation and the beta radiation just as a matter of, what you do. You kind of have to do that, to discount those things in various places. So those were basically background. I'm interested to see what you would see on the film that I exposed, the 400 ASA film. But in all honesty, unless you're kind of starting to see those things flying around, you're probably not going to see that, because it might actually just be working in this catalytic chemical process, and which has a lot of merit and potentially is producing a secondary energy source that can be used in other ways without impairing the overall efficiency or even increasing the efficiency of the original device in aggregate. So cleaner, leaner, and potentially providing another engine or another means of energy generation in a sequential step. So Paul O'Neill, I'm waiting for someone to using this tech to accidentally create a coherent energy sphere or mini sun. Malcolm Bendall has described an experiment, and I didn't see the Pantone one. I didn't see other things that other people have claimed have disappeared over the years. I have seen in Henk Uren's videos where an area of copper goes and it disappears. I have seen the aftermath of these disappearances, like in the Lion cores and in the Hutchison samples. So I don't think that these are not things that are possible. And I have literally, we've seen this disappear in the Vega experiments of Henk Uren. So this is a thing that can happen. And if you had those 2 poles in the non-radiating boundary, and you're charging it and charging it and charging it, by the only thing that can charge it is other things with the toroidal moment that can speak to the inside and exchange their energy with it, then you could get to a point where it just goes and it makes the thing disappear. And this is not ideal. I think we can do a huge amount of good with the embodiments that I've already seen, but working as best as they're claimed. And even accepting that carbon dioxide is coming out rather than disappearing at this stage, the profound ability to massively impact the lives of people around the world by reducing the energy usage, allowing methane hydrates into the fuel supply, and the stability that will engender by having a system like this. I think it's got huge merit in its own right, without going into the more exotic reactions. Did you learn? So Adonis said, did you learn anything new about how open source this invention is? The only way this makes a difference is many companies and startups take it up. Well, I think it's even more open source today, potentially, if it is doing this hydrogen reforming than was ever possible. Because, like, he's been open enough, and the other people doing the testing, like when Nikita asked me, you know, could he have my views on X, Y, and Z? And I said, well, I'd be happy to do that if I'm going to help you if we post this openly on the Martin Fleischmann Memorial Project's website. And he agreed to that. And it's only because he published this data, which he says it's unusual, and where's the hydrogen come from? This can be seen on the gas analysis graph where hydrogen and carbon dioxide sharply drop off, blah, blah, blah. Notice this. Where is it? Yeah. La, la, la. Interestingly, the exhaust all contains a surprising amount of hydrogen gas. Right? Yeah, the hydrogen gas. Okay. And it's only because he shared this and that openness that we are able to think about what's going on. And of course, what you need, as I said in my initial presentation in Zurich, what you need is a whole bunch of hydrogen gas, potentially, and bunched electrons. So when you've got these kind of situations, you've got more likely to produce the exotic vacuum objects, the ball lightning, okay? So, and the hydrogen is, like I say, 2,000 to 4,000 times easier to produce etheric matter, according to Shishkin, Karols, and Dubovik. And so you've got to have the hydrogen to begin with. Well, this is making the hydrogen. And partly that's what's coming out of the engine, and potentially the rest of the process is occurring in the Thunderstorm generator. So, in terms of being open, you can see the video that I published today. He's literally given the device that was there at Zurich to the German team that helped make it. Like, I watched them build it, and it wasn't Malcolm doing most of the work, it was them. And they're able to take that away and do what they like with it. He's promised conversion kit for a 1300cc Golf engine for Henk Uren, and another one for Tony Yaboni, and another one for use in England by another collaborating MFMP researcher. And so I don't know how much more open you can be. We've already defined what the UV lights are, and potentially improved UV lights. And so I suggested, for those that didn't know, this is the exact UV light European version that was used. It's got 300 nanometers, 4.1328 electron volts, 45 microwatts per centimeter. This is 2526. It's not new. Sorry, I'm not showing you. It's not new, the idea of pre-ionization to make clusters. It was done by Paul Collock and Papp and Hutchison. But there are other lights, and if you use these lights, unlike this one, which is for pets, and the UV photons are I wouldn't. It's relatively eye safe. I wouldn't suggest looking at this at all because it's still got mercury in there. There will still be traces of the higher energy photon line of mercury, particularly as the bulb gets old and the phosphor wears off. You might get that, but it's the pressure of the mercury. Low pressure mercury produces more of the 180 or whatever it is nanometer line, but it's this 254 nanometer line which does not produce ozone because we want to keep that paramagnetic oxygen in play. And we're going to be looking at using these for producing ionized air going into the wind hex. And there's a lot more to share on the wind hex. There's a huge update coming on the wind hex. Fantastic work being done by Henk and by Tony Uboni. And this all needs to be filled in with you guys. But this device down here is 25 microwatts of CM, but it's actually at this higher energy photon line. So you're going to get higher energy electrons from the photoelectric effect off your titanium dioxide, and more effective photo catalyzed dissociation of water producing hydrogen in there. And it's only 3 watts. So to create the amount output you've got here, 45 watts at 20 centimeters, you only need 2 of these running. 45 microwatts. This would produce 50 microwatts for only 6 watts, right? And it's a higher energy photon beam. So this is far, far, far more efficient. So there's all kinds of ways this can be made more efficient. And I'm going to do a video on specifically addressing this subject. But it is this thing, these kind of like ejections here that you'll see here in a minute. One went off that way, and there'll be other ones there. You see it. These things coming out of the engine, which are the things that we possibly are more exotic. And I showed in my conference speech that in the Maldives, he was looking at 23 to 26 grams per meter cubed of water in the air. Because the air temperature is higher, it can carry more moisture in a kilogram of air, as you can see from this chart here from Wikipedia, the relative humidity here. But this is the absolute humidity. This is the actual carrying capacity of the air. And of course, in central Thailand, that was 7 to 10 grams per meter cubed. Sorry, central Thailand here, rather, is 21 to 30 grams per meter cubed. So where he had that effect, you're talking about 2 to 3 times the amount almost of the water vapor that is present in Hessdalen when the Italians Massimo Teodorani and Gloria Nobili recorded this ball lightning in Hessdalen Valley in Norway, where they're seeing like around about, let's say, 10 or less, a little bit less than 10. So they almost triple the amount in central Thailand where he observed that effect. But of course, the bubbler is vastly increasing. And it's like I said in the presentation, it's a trade-off between the inability of the gas to be, the inability of the photoionization and photocatalytic dissociation of water producing the initial hydrogen, produce the initial clusters with the photoelectric effect, as per the work of Matsumoto here, to get your protons and bunched electrons, and the having too much moisture in there where it doesn't actually allow the light photons to get to the metal or the metal oxide. Yeah, so as Alex Del Castillo says, is, oh my God, so true recatalytic converter, right in our face. Yeah. And it is only because it's just, this is the beauty of the open process is just sharing this data, going, I don't understand why we're seeing extra hydrogen here, and then Malcolm being open and saying that the devices work better when he uses steel, which acts as a catalyst. And then I confirmed with him today that he preferentially uses 304 because that was more available, or 316, and those have 8 and 11% nickel in them, and that nickel is used as a catalyst in steam reforming. You then start to put these pieces together, and it makes a logical argument. You are going to be better off with the lower carbon monoxide, the lower carbon particulates, the lack of soot, the lack of carbon deposits, and the lack of the full burning of the HCs is all going to be there. But I think until I have tested a claimed carbon monoxide and carbon dioxide claimed non-emitting device, I think it's due to the way those detectors work, with the IR being absorbed by this excess hydrogen production. No, glasswork won't be suitable, I don't think, because you need this electrical connection between the two. So like if you've got clusters will be made whether we like them or not, and whether they're up at a very high level in the plasma in the combustion chamber. And as that comes out and some of those clusters are failing, they will share their electrons, which will go through the metal and charge the incoming gases. So they're not only going to be this flashing to steam like the Armstrong electrostatic boiler charge separation. The turbulence in there will also be able to capture the electrons released from the plasma that's coming out of the engine itself. So there's two ways in which there is this harvesting of otherwise lost energy and lost excitement, lost far from equilibrium. Yes, Tristan, this is why the devices that they are graciously saying that they will allow us to have in order to test this ourselves, it's expensive, because stainless is not an easy thing to be able to weld. There is some talk about using direct laser metal sintering to produce the things in one piece without any welds. And you can do things like Inconel and stuff like that. Obviously, Inconel has nickel in it, so that might actually be an appropriate way to do this. So I mean, the point is that there's ways to get around this. If it is just a process of catalytic steam reforming, you might actually just be able to buy, and this is from Johnson Matty, some steam reforming catalysts and put them in a tube, like. But I do think that you're going to need this exchange of charge separation and optimization of the shift between one and the other. I don't know. Maybe it is. Maybe we can solve this with just steam reforming catalysts. Or maybe you can do it in normal mild steel and then insert along the length of, with a thin insert with some, stainless steel, like just a cylindrical section inside the mild steel. So you weld it together with the mild steel, but you insert the catalytic surface containing the nickel, and just do it that way. So easy construction, but still performs the same process. If indeed it is this partial oxidation hydrogen reformation that's going on that is producing this extra hydrogen. Yeah, I think Stanley Meyer was definitely into this whole ballpark. You think adding carbon particles gives extra power and output? In theory, if it's kind of using this process, one might imagine any source of carbon would be suitable, and even carbohydrates or anything. All the claims made for GEAT kind of would apply, but what the GEAT is doing, certainly is claimed to have been doing, is to be splitting up the material into carbon, hydrogen, and oxygen, and effectively, like, by getting the ratios right, you're doing your hydrogen reforming and so on. So, like, there must be an optimum, right, in the process. So, okay, so Hominidae Theodosia is saying, Bob, seriously, go and look up the gas core transformer of Stanley Meyer. You will be amazed. Okay, I will have a look at that. Go to remoteview.icu, please, and put down the links that you think people should be looking at on those. That would be great, Hominidae. Thank you very much. Is this a monoatomic reaction? There's a lot of monoatoms going, like, kind of. No, is it? I don't know. Okay, so is this a monatomic reaction? Look at what you've got here. Half O2 is basically a monoatomic. It's atomic. It's basically O minus, isn't it? That's going to go and react with this. Yeah. So, I mean, one could argue that if this is the reaction that's occurring, then, and it's purely chemical, then in this instance, you probably do want to ozonize the gas going in. And in that case, you really do want the higher energy photon line of the ozone producing mercury lights. So, that's, but if you're going to be playing with those ozone producing lights, you've got to be very, very careful. Just that they can make you go blind rather quickly. I've got a big one next door. I don't look at it. Just go to so Hominidae Theodosia. Go to remoteview.icu. That's the letters ICU at the end, and you can go there. You can see the latest blog is the trailer for this discussion tonight, and just dump the links in there. You might need to. I don't even think you need to register. You might need to register. I think I want this as open as possible, so that's probably what I did. Aedionis, thank you for answering previous questions. What do you think about Malcolm's plasmoid unification model? As I said when I first someone reached out to me and put me in contact with him. The man in the street cares about, in my opinion, a few things. Does it work? Has it got utility? Is it safe? And then probably, is it affordable? Those are the things that people care about. In reality, there are other people that will want to get into the nitty gritty once it's established, not when it's all up in the air. But I think we're getting quite quickly close because of the openness from Malcolm, because of the openness with the people replicating this. we're getting quickly to an understanding, although I may be wrong, but I think that the evidence stacks up. And so for me, if you look at what happened with Lion chose to put two thicknesses of copper in between the fused quartz here, like, so you have the heater on the outside, then the fused quartz, and then inside there he had two layers of copper magnet wire. He put that in there because he thought that it would be a good thermal conductivity between the quartz at a temperature and the inner core of the reactor. Of course, copper is very good at thermal conductivity. If he had not done that, then I would never have seen the birdie. That's the logo for remoteview.icu. I would have never seen the Lion pore tracks, the actual strange radiation tracks. I would have never seen the north and south yin-yangs. I'd have never predicted that from the X-ray that he sent me and then seen it on the X-rays afterwards, which is the kind of frozen in input and output, or rather output and input of the flux loops, which we are seeing in Malcolm Bendall's Thailand test. He did it for one reason. It produced a reactor that did something frankly amazing, and it led down a whole series of understanding and re-engineering and rediscovering what it would appear, or rather realizing what it would appear people knew a very long time ago. So it doesn't matter, in my view, how someone comes to a particular answer that does something that helps humanity. It's just that they do. And I really appreciate people that do. And if they're not hurting anyone with an idea, then let's have a discussion about that idea. Do I think it greatly helps me to explore this particular technology right now? I don't think it does. Does it help me completely understand it? I don't think it does. Is he wrong? I don't know. I know I've been wrong about so many things, so he may be right. But from my point of view, I like to see what I can see, which is repeatable through empirical evidence and experimentation. And those are the facts that I can rely on. And so, you know, that's how I roll in this situation. Do you want close up of that? I've given many close ups of the tube there. So more on the vacuum pulse. Okay, so like I do know that, as I showed in the videos, because they couldn't modify the generator, the 400 kilowatt generator, whatever it is, in the UK, they had to add a blower. Now, as I understand it, the similar type of thing that he had in Melbourne, that wasn't required because he could modify the actual device. Now, I think that's going to go down that route, so it should be able to be without the blower. I do know that to get things quickly working, they are adding a small vacuum cleaner, literally electrically powered vacuum cleaner, that's taking electrical power off the generator, the small Honda generators, to assist in the vacuum. But again, he says that that is not necessary when you create the right custom parts. It doesn't really matter, does it? If it actually works and is more efficient and is cleaner and potentially is producing this hydrogen as well. If you're using some of the electricity, like some of the electricity in a car is used for the lights and the radio and the alternate, you know, is used to some of the power of the car is used to recharge the battery and these kind of things. So it's not an unheard of thing to apportion some of the energy to provide other functions in the car that are necessary for its efficient operation. So yeah. In terms of the vacuum pulse itself, if you've got like air coming through and water moving with momentum because of the vacuum cycle, and then the valve shuts, and it basically is like a water hammer. This will actually cause because of the low pressure, you get the dissolved gas forming a bubble, and also you might get cavitation bubbles forming. And then as the water hammer process hits, those cavitation bubbles collapse more violently. And so you've actually got cavitation going on in there. So, you know, and when the bubble forms, it's going to have to form into an environment where it's got this metal pan scrub, and that's going to slice up the bubbles. So you're going to get all kinds of division. And as I described, that the pressure in... And this comes from Bin Huang's 2019 presentation on his cavitation system. And he shows the calculation there. You can go and see it on the MFMP's YouTube site. I think it's... when you get down to 1 nanometer, it's 2,760 atmospheres. And you go 10 nanometers to 2,700, 276, and then 100 nanometers. And 100 nanometers, actually, this is actually a real figure. That is where, around 100 nanometers, is where gas bubbles can persist in water for a very, very long time. And so, like 100 nanometers, it's 27.6 atmospheres. I think it's off the top of my head, or something like that. So there's a lot more atmospheres in there than the air that's surrounding it outside the bubbler, which is just a single atmosphere. So are the German team who have the Zurich model going to put any information online we can follow? I will encourage them to. I will certainly reach out to Malcolm. Like I said, I have been sent some images of their modifications. They were very happy, and I asked them before I recorded the videos of the build in Zurich. They were happy to be on camera, so maybe I can reach out to them and get them to share their observation. But I think you're going to see the same thing. I think this is... if it is a hydrogen reformation system, it has the nickel in there to do it. It has the temperature, it has the water going in to play a role in doing that hydrogen reformation, and the water is as steam, and the heat exchanger allows it to be in high temperature steam, and so but it's not as good as the normal system because you've got nitrogen in there. It's not a lot of oxygen, not at very high atmospheres, but it is at least the partial oxidation process. So I don't see this not happening in their device as well. And so I believe that when they analyze their gas, they will see hydrogen. And I also believe that they will see raised oxygen because there's a balance of oxygen coming from the water, or rather there's not so much oxygen used from the air. And it might be that I don't expect to see the hydrocarbons there. I don't expect to see the carbon monoxide there. But I do expect to see potentially the carbon dioxide, unless the process is pushed to the point at which the carbon is being removed in the ways that we know it can be removed by ball lightning. And so if you are producing those clusters that are big enough to start producing the ball lightning, you will get the silicon formed, you will get the iron formed and calcium formed, and these will take the carbon out of play. We may have an answer for that, or we might get, sorry, the last type is actual particulate carbon in the form of like diamond, so it's not like graphite or P10 particles, it's actually diamond deposits. These were seen by Leclerc, they were seen by Matthew Villatte on the Chelani wires in early 2013. That's what actually led me to suggest nickel diamond super abrasives, and that's what led to Lion ultimately. And so the diamond synthesis is something that is observed. Like in the Vega Valley, on the end of the fluffy carbon, there's a little diamond on the top of those. So diamond does get synthesized by these things. Is the diamond encapsulated in an exotic vacuum object? The exotic vacuum comes out as a neutral. and the diamond is deposited somewhere else, and it's just a little speck and no one's ever going to see it. You know, there potentially is ways that this could be sequestered, but until we have an understanding of whether this is because of the detection method with the thermal IR, we don't know whether the carbon is really being got rid of at this stage. But there's still so many benefits to this process with this potential added bonus of the hydrogen coming out, which is a secondary fuel. So RA says, have you witnessed the engines under load? I have videos of the natural gas powered, that's the methane powered generator running at 200 and 300 kilowatts. And that is on load because how it works is it negotiates a load from the grid and it supplies that energy to the grid. So that device in the UK is perfect for testing. The other device that I saw in how should we put this, in Zurich, that was on load, and I think it was either 2 or 2.5 kilowatt thermal heater, and you can see that in some of the videos. So yes, in both cases I saw them under load. So I believe there's going to be a press release tomorrow. Potentially it's today here. It'll soon be today in the UK. So there'll be a press release, I think. I don't want to get ahead of this, but on mass manufacture agreement. Let's see if that comes out. And I'm hoping that the other data, which wasn't presented at the presentation, it's not my data, and I know that the person preparing that wanted to verify and stuff. If I had it to share, then it might even be wrong. So that's why I only chose the slides that I did today that were already presented at the conference. So yeah. So how is this better than GEAT reactor? Because it's much, much simpler. It's much simpler, and it's probably mostly doing the same thing. For the GEAT that most people were ever able to produce, if they could get it working, it was probably doing this. And the other thing is, it doesn't recycle in the versions that we've seen. It doesn't recycle it into the engine. Maybe if it did through the bubbler, it would be more efficient for a period of time, but then you have an issue that the water is being changed. So it's just simpler. Like the idea that two novices could take highly non-ideal equipment and put one together in a morning, and I witnessed it. And these are people that have not done. These are not unskilled people. Klaus and Dr. Thorsten Ludwig are not unskilled people. They're very skilled people. They've done a lot of different things for many years, but they're new to this thing, and they put it together with less than ideal tools in a less than ideal environment with less than ideal fittings, and they managed to achieve some of the claimed effects. And the reality is that if you see the CO go down, and you see the HCs go down, and you see the CO going down, that is, if I'm right, because it's actually if it is doing the hydrogen reforming and it is creating this hydrogen, and the reason that those are going down, it means that their device actually did this process, right? If I'm saying that the hydrogen synthesized is masking the signal from the carbon dioxide or carbon monoxide, but the carbon monoxide is probably gone anyway, because that's the one that does go to zero, right? In the ones that the tests that I've seen, the carbon monoxide goes basically to zero. But it might be, and probably someone could find this out before I wake up in the morning. Is there a thermal signal crosstalk, absorption similarity, or rather does the absorption of hydrogen of IR light used in these devices interfere with the hydrogen, with the absorption lines of carbon dioxide in these devices? And it's not normally a problem, because you normally don't expect to see any hydrogen in the exhaust. Is that why you don't see the carbon dioxide? Regardless, the fact that we saw that reduction in carbon monoxide, and the fact that we saw the reduction in carbon dioxide, would mean that the hydrogen reformation process is going on, and that 2 novices using the wrong equipment and the wrong fittings could readily get this to work. Means it's so much easier. You'll have to spell that out for me. Nick Knox says, Bob, did you witness any improvement in BSFC under load in the UK? You'll have to spell that out in English for me. And it's also like there's a guy in the UK that reached out to me before I went to Switzerland, and he said, like, we've been doing this same kind of reduction in pollutions for many years, and this was also a claim of HHO researchers. It was also a claim of Roish and Amarza. But in the case of HHO and Amarza, they are literally, Amarza's producing the gas somewhere else and injecting it. And HHO and hydrogen injection are having to have some other electrical equipment that are doing that. All of those things are, in my view, inferior to the GEET. And the GEET, because the GEET is a flow system, it's producing it continuously as it's needed. And so it's safer. But then this system looked like it's doing essentially the same job as the GEET. And you don't want to get to the magical bits where things are disappearing and doing weird stuff. This is doing the same thing as the GEET, but it's like, much simpler to implement, it would appear. Break specific fuel consumption. Right, so I wasn't there for any tests where I saw an amount of fuel put in and saw how long it lasted. They're doing the fuel efficiency typically by saying, we are running a fixed load and we are going to put in, let's say, 1/3 of a litre of fuel, and we're going to see how many minutes that lasts for. Now, typically, what they find is with no load, it's actually less efficient. But when it's on load, it's more efficient. And the data that is publicly being mentioned is up to about 13%. Malcolm claimed up to 50%. I haven't seen any tests of that nature. I hope to see tests of that nature either in the UK at some point later in the year, or potentially there is another conference being conducted, I think in Germany. I got an information about it on the 11th of November, so coming up quite quickly, and I think the one that the Germans have will be moved there, and they might run some more tests on that. And Malcolm said you can have the device and you can do your own efficiency tests on it. And so I think possibly they will run an efficiency test either before that or actually during that conference. So there may be an answer from a third party in a live event sooner. Right. Okay. So you're saying load is stronger vacuum pulse. I don't know about that. I don't know about that. It's not a specific claim that I've seen, so and maybe that will become later down the line. So Felix says, I like the idea of a simple bubbler ionized water vapor rather than HHO. Yeah, definitely. If it does the same thing as HHO, then fine, great. The gas was metered, but I wasn't monitoring that, and I'd like to see these things run for a whole day and measure the gas, and then a whole day. But for the particular device in the UK that I saw running at up to 300 kilowatts, firstly, it wasn't run for very long, and secondly, they had this separate blower providing, and it was a diesel blower, so like there was no way you could reasonably do an energy balance test on that, because they couldn't modify the engine. Now they're in a position to modify the engine. They can do what was apparently done in Melbourne, and then they could do that kind of testing later down the line. So the focus of the testing I think in the coming months is going to be on 3 classes of engine that are typically used in electrical engine, small electrical generation technology. So Herman Dalton says, do you think the shape of the chamber could make any difference, and egg shape rather than sphere? Just thinking to the work of Victor Schauberger. Well, what I can say is the coupling between the device and its pipes, Malcolm believes it's very important to have these sort of curved sections, which you can see here. And he says, and I don't think this is accurate, but he said in the presentation that I've published in the public forum in Switzerland, that this is the angle of the slope angle of the pyramid, although it is a curve, but if you draw from this point to the other point, it is that, and he thinks that's important. It may be. So this is not technically a sphere. The only one that's really a sphere is the one in the middle, and I'm not even sure that that is actually a sphere in the ones they've implemented, because I've not seen the inside of it. But these are predominantly sphere, and then they blend in. And this, if you drew a line between here and here, it's meant to be like the angle of the Cheops pyramid slope angle. And I don't think that's what is being shown here. So that is critical information according to Malcolm. And it's to do with in his view, the way the vortex material is going down. It's less disruptive to them as they're going through into a different pressure domain or a density of vortex or whatever, I don't know. But that's his view on it. And there we go. I think it's 51.84 degrees, I think. Yes, Martin. As I said, 51.84. What about strong LEDs for water vapor ionization? Well, yes, that's kind of like what I showed in my presentation in Zurich, these LEDs. And I will do a separate video on the whole ionization process because, and it's relevant for ionizing and ionizing. Like I say, potentially you might actually want ionizing in this situation if you want to maximize the but I would suggest not, because it's just too dangerous. Even this is dangerous. So I will talk about these, but these are the LEDs, and you can buy these individual LEDs, but they're so much cheaper to buy them in a pack like this. And then I would look to arrange them differently personally, and I will go into that and why. So, dear Dazzle, why all volcanic ash or volcanic stone generate low energy nuclear reactions? Well, certainly if you've seen many volcanoes, they have lightning, but they also have ball lightning involved with them, which means that they are getting into the right domain for producing charge clusters of extreme size and scale. And so one might expect there will be nuclear reactions going on. Certainly in Matsumoto's book, Steps to the Discovery of Electronuclear Collapse, which you can get from Amazon, or you can, for cost. In fact, I think it's even at cost completely right now because the cost of paper went up. I don't even think, maybe they can ship them still. I think the project gets 1 or 2p from the sale of one book. So it's right on the dividing line now. You can download it off remoteview.icu. So just look for Matsumoto, and he talks about how the volcano may actually be one ball lightning, or rather this process going on under the ground. So can corporations around the world start research and building prototypes of this? We could do some activism and start spreading the word about this technology. I think so. Malcolm's view is the specific form and function of, like, so for instance, as I said, the how should we put this? The ionization is not original. The counter vortex is not original. The GEAT is a patent that is now expired. There are many vortex separator type patents. There are many heat exchanger patents that are long expired. So it's like having a phone and you're patenting the curved corners. He's specifically, I guess, applied for a patent in as far as I understand, in the ratio of the circles and the curves into and the reason why. Certainly a bubbler is in a GEAT pattern as well, and so forth. So I think that's what he's done, but he tells me that the reason that is being applied for is to prevent the technology being stopped or blocked by a third party that comes along and has that sees his design, patents it, and then says, now you can't use it. Arbu sucks to you. So I think that's what he's saying. And his view is that they will be in mass manufacture, and it just will be cheaper for people to buy a kit or to buy a unit where they're already on there. And I would tend to agree. As someone already identified, and people may well know, it is a real pain in the proverbial butt to produce sections like this and then weld them together in stainless steel. So yes, it's a pain in the proverbial butt, and so it will probably be cheaper rather than someone having to buy all the equipment and all the materials and failing 10 times and it ending up cost them £22,000 to make it. It'd just be easier for them to buy something for $100 or £100 or something and throw it on, or buy one that's it's already built into. Riandolthal says, can't the flow patterns inside spheres be simulated? Absolutely, and I've suggested to colleagues in the MFMP that hopefully Chris out in Australia would like to do that. But then it would be better to have the actual layout rather than these rough assumed drawings by a third-party replicator as a kind of like a fact base. Yeah. Yeah, I know water absorbs a lot of IR, and so it may be playing a role depending on the concentration of water, but these devices do expect to see water, so they actually detect by looking at specific frequencies that are observed. So what I'm asking is, and I could probably have found this out beforehand, and I could probably find it out relatively quickly now, but I just wanted to start talking about this particular concept, that I believe that hydrogen reforming is potentially a key part of what is going on. And it would explain the data, and also why stainless steel of the types used seem to promote the process and do a better job. And he's literally calling it a catalyst, but a catalyst of what? And I didn't really get that out of him. And if it's a catalyst that seems to make the process work better, then it's not really describing what the catalyst is actually doing. It's just other than making the outcomes more desirable. But if it's a process that leads to more hydrogen reforming, which something with nickel would do, then one might expect that then it would be catalyzing the observed process. I don't know, actually, DIY with Chelsis. So I think the pH, he thinks that the plasmoids are being produced when the water is more alkaline. I'm suggesting that the water might be becoming more alkaline because the cavitation is either producing deuterium and capturing 2 hydrogens effectively and leaving more OH behind, or the photo dissociation of water is pulling in OH ions into the water and making it more alkaline. So I think there's some potential confusion. I might be wrong. He might be wrong. There might be some switching of cause and effect there. Yeah, pipe, thumb hands. I like pipe more than pip. You can use copper oxide for the photoelectric effect. It's actually quite effective, and that's what was my suggestion for what we're doing in the Vega experiments. Personally, I would prefer yttrium thin film on the copper oxide, but that would be expensive to do and so on. So like copper oxide is just great on its own. Even zinc oxide is very good. I think it's got a very low photoelectric effect, but it's where I think it may be important is the photocatalytic splitting water, which the titanium oxide and doped versions of that do a better job. And so in any case, I think at best that the photo part of it is just creating the seeds, the little the initiation of any clusters that are involved. But I expect as more people replicate this, they'll take off the ionizer, they'll take off the bubbler, and is it just the thunderstorm generator? And if it's just the thunderstorm generator, then is that sufficient on its own to do this hydrogen reformation process? Well, no, because you probably need the bubbler. Why do you need the bubbler? Well, you need to increase the amount of water in there. And the bubbler, as I said, in my view, is maximizing the amount of grams per kilogram of air, of water that can be taken into the engine safely. I need to get a clear tube pipe. You can actually, I don't know exactly, but you could, I should have measured these things, but I didn't. But you could easily reverse engineer that from the photos that I've shared. And I'll share a whole bunch more photos. Yeah, you need the water vapor. Yes, Felix, yes. Yes, the water vapor is key. You don't get no steam hydrogen reformation without water to make steam. Yeah, so 200 nanometers is, and it's not just about being 200 nanometers. You need 200 nanometers, and then you need some for the high. The easier it produces electrons, the faster the electrons will come off with any incident photon. So I'll do a presentation specifically on the photoelectric effect. I'll do a specific, and that might be the same presentation where I address some ideas that people might like to consider for optimizing the potential for doing what is being suggested here by Matsumoto. Yes, RA, there's many angles where this can be researched. I think probably in my journey of evaluating this technology, other than physically seeing it and seeing the lack of carbon dioxide and seeing the lack of carbon, the lack of carbon deposits is telling the biggest part of the story, and then this hydrogen here is telling the biggest part of the story. It's telling me that probably all of the carbon is becoming carbon dioxide at least, and so the process is working, and that's what you would expect from a total burn. And if you're seeing the hydrogen here, then possibly it's this hydrogen reformation process, which also works with petrol and works with methane and tip gas, all of the things that have been shown. Now, the GEAT claims to work with crude oil. Now, that might be true, and it might be true because it has the central rod in there and it can smash up these things, and it's basically a fracker. It's a miniature oil refinery. It's taken the high, chain length hydrocarbons, and with the water and steam, it's basically fracking that thing. So the view with copper, from my point of view, is one, it's conductive. So if you do want to shift some excess charge to areas where you want the photoelectric effect to take place, that's good. It's easy to form copper into bends. Copper is diamagnetic, and so if you have a charge cluster and it gets close to the copper, unless it's breaking up and sharing its electrons, it's going to travel in that thing. So, like, you have these charge clusters being able to travel down an 8-micron wire and then light 25 kilowatts of light bulbs, and that wire is the thickness of human hair, and it's copper because it's running along as a guide. It's going along as a guide. So the copper is, because of its diamagnetic nature, is providing a guide, but also the copper oxide, if you do get to the point of your cluster being in the white mode and it is cohering and condensing the electrons, then it will be emitting these 2 kiloelectron volt photons, these soft X-rays, and they will massively increase the production of electrons, which will then feed the exotic vacuum objects themselves, the microball lightning. And this is one of the basis for the energy gain process in one of the patents or embodiments of Ken Shoulders for manipulation of exotic vacuum objects. Yeah. So Felix, I still, my first point, as I said, what is going on? My first point is, I didn't know in Zurich exactly. I had some suspicions, but at that time I didn't have a formatted hypothesis. But my first point is, where does the carbon go? And it's like, well, it hasn't gone, but it's just because of an error in detection. But I can tell you, I couldn't smell the HCs, and I suggested you needed a budgie or a canary in a coal mine, for instance, is the phrase one might like to use for carbon monoxide, because the lethality for a canary is the LD50 or whatever it is, the amount of carbon monoxide a canary needs or a budgie needs is lower than a human, because they're just bigger. And so if the budgie keels over and falls asleep or dies, then probably the carbon monoxide is still there. We're just not able to detect it. I don't think the carbon monoxide is there. I do think CO is there. And therefore, you just need some particular chemical, which might just be calcium oxide. And you pass the gas from the device through calcium oxide. And if it becomes calcium carbonate, you definitely know CO2 is being produced. But yeah, so my first port there was error in detection. So we just need to clarify that. But other than that, there are still so many ways in which the extra efficiency, the extra cleanliness in the output, and the simplification over other technologies that's been able to show this in the past, the continuous flow and the lack of need for a catalytic converter, and this may actually be quite a lot cheaper than a catalytic converter but perform the same role. Everything else is a bonus after that, and if you're getting an extra energy source which you can find some way of using in this hydrogen that's synthesized, then wonderful. Hi, Crypto Alchemist. Was there any white calcium powder deposits witnessed from running a generator in the UK? I haven't got to look into a long-running generator, one of the smaller ones. I didn't see anything particularly that was calcium, but then maybe you don't see it. When I look at the things that's in the Vega Valley, Eastern Plateau, it just kind of looks like a rusty kind of deposit, and it's only when you go into that you see these structures which are pure calcium oxide. So let's see if I can get under the SEM or on the sample on the SEM. You know, these questions will either be not answered or they will be categorically answered. Neanderthal Bob, what about the EVOs emitting from the spark plug? There will definitely be EVOs there. All right, I'm going to say thank you very much for your time and your attention this evening. RA says one thing. Are there any safety concerns that you think have yet to be addressed? Yes, for an overdriven reactor, I think it will be potentially producing strange radiation. Like I say, I've already had 400 ASA film exposed to the 400 kilowatt generator in the UK. I will be developing that over the next few weeks, and I will be analyzing that at 36 bits at 2,600 or whatever stupid DPI to see if we've got any birdies on there. So jury's still out on that. I would like to do long-term tests on a working generator that they claim is working in the UK, with a range of detection methods, including the real-time strange radiation detection method I developed using a webcam and a cosmic ray finder. I had that all set up again. I took it all with me to Switzerland. But like I say, because the actual device that was pre-built never turned up and they had to build one on the fly, there was never any time to do that. So probably a best thing. It's given me more time to try and understand what's actually going on. And as I found in this journey, it's only you only get to see only exactly what you need to see at each part of the journey. You just have to keep ploughing forward, and it's just a long slog. The CR39 method, well, it's not conclusive, CR39, because strange radiation might do that, or it might be high-energy alpha particles or whatever. So yeah, maybe not. So on that note, I'll say thank you very much for your attention this evening. This was THOR looking deeper. We had a look at the actual sample over here of the bubbler, and we can see that it's probably some silicates in there, fragments of possibly glass bottles sintered together, and we walked through very essentially that probably this data here with the hydrogen forming here may be due to hydrogen reformation in the partial oxidation method, and that would explain why nickel, which is used in steam reforming catalysis, potentially plays a role in stainless steel, acting as a catalytic role to improve the observation of the supposed dropping in carbon dioxide and increase of oxygen out. And this was not discussed by Malcolm, but it's there. So there we go. All right, so thank you very much. And so Odd1X says, hi Bob, when do you think you might have some time for some Q&A? Possibly. I might do just a couple of videos in the week, and then yeah, let's send me a proposal for what you're thinking, and we'll go from there. So thank you very much for your time, everyone. Buenas noches, dobranoc. Good night. Buenas.